Hey everyone, welcome to another practice video on standard error of the mean. I'm looking at the bottom of page 17 and we're doing something very similar to what you guys are going to be expected to do next class period with the FRQ. So you'll be given some background information about a study or an experiment or something, and then you're going to be given some data and asked to draw this data. One of the things that we're going to do for this particular example is we're going to focus just on going one standard error of the mean, but understand that this can actually go up two standard error of the mean. And when we do that, when we graph the information, we're going to be looking at data that's already been given to us. So on this particular example, we are not going to do part B together, but I'll explain what to do in that situation. So the first thing you want to do is you'll want to graph your data. You'll want to put on the bar graph, in this case, it's the averages for the 6 weeks. So you don't want to shade in the data when you draw your bar graphs. You just want to indicate where they would go to. And don't worry about the lines being perfectly straight. If you guys are doing this in pen, which you should be doing, you can always go back, put an X over the one that you make a mistake on, but you can add stuff later. So once you have graphed the averages of the data, now you need to go in and look at the standard error of the mean. So when we add the standard error of the mean, we're going to use the data that's given to us in the table. You have to find out what the maximum and the minimum for each of these bars is going to be. So for 18, we're going to need to go up 18.9, and then we're going to go down 18.9. Sorry about the bell. We're going to go down 18.9 again. So the upper extreme of this SEM bar is going to be 18.89. And then you have calculators. You're going to subtract these to get the lower extreme of your bar, so it'll go to 17.1. So on the graph over here for category 5, or students who got a 5, I'm going to go ahead and take my upper extreme, which was 18.89. I'm going to draw that in, and I'm going to write it right next to the top of my SEM bar, and then I'm going to draw in the lower extreme, and I'm going to write that in as well. So now we've got my upper and lower extreme of those SEM bars. For 4, again, so we're starting at 16, we got to get the upper extreme and the lower extreme. So the upper extreme would be 16.74, and then the lower extreme is going to be 15.26. And I just did this on a calculator. So get your extremes and then come over to your SEM bars and draw them in. So we're going to start with the 16.74. Now we're going to draw the lower extreme, which is 15.26. And now we've got our second bar drawn in. The last one, we're going to do the same thing. Our upper and lower extreme, so this is 15.2, and then our lower extreme is 12.8. So over here, I'm just going to draw those in, 15.2, and then my lower extreme, 12.8. And so here is the data for our students. Now make sure that when you write your conclusions, you indicate statistical and whether or not there's a statistical difference, and you include those SEM bars. So are the SEM bars overlapping? If they're not overlapping, such as they are between 5 and 4, then you say there's no statistical difference between the two populations. They almost overlap for between 4 and 3. You could argue, I would argue that that there is no difference between a 4 and a 3 simply because the SEM bars are just too close. There is almost that overlap. Now, if they ask you on the FRQ, if they ask you to graph, like on part B, where it says to show within the 95% confidence interval, in other words, 2 standard error of the mean, you would do the exact same thing that you did up here. The only difference would be is you multiply this value by 2. So you would go 0.89 up twice, then you would go 0.89 twice down in the opposite direction. So I think it's easier just to multiply these by 2 if, according to the instructions, they tell you to go 2 standard error of the means up or down, then you multiply your value here by 2. So once again, if in the instructions they tell you to go 2 standard error of the means, then you got to make sure that you would multiply each value by 2. If they ask you for 3 standard error of the means, then you would multiply each of your SEM values by 3. So pay attention to that wording. It can get a little tricky. I hope this helped, guys. Thanks for watching.